That is crazy. I'm studying for something. Is it hard? Is it hard?
Okay, guys. First thing, a relation is a set of ordered pairs. Set of ordered pairs. Fill in that first blank. Please fill in the first blank. So, I know there is a bracket here. What's in my pen? So the example that they're showing over here, you got yours? Here. You're doing it, you're talking. Carlos, I don't need you to continue to have a conversation. Heidi. Okay, so order pairs are your X and Y's. This is an example to show your X coordinates, which is in this set, they're using a bracket to show a set of order pair. Your X coordinates are the first numbers, and your Y coordinates are the second numbers in the order pair. So there you need to be able to pull that value out, because the thing you have to understand, this is what I'm going to ask you to be able to interpret or kind of problem solve with. Your domain, is the input or the X values. So when I'm talking about domain, I'm talking about the X values in the order pair. So if I'm looking at this example, the domain would be which values? Which are the X coordinates? The first numbers, guys. 1, -3, 0, and then to put that on your notes. Domain are the X values in your order pair. Another name for domain is the input. Your range are the outputs. Set of the output values, which is the Y values. So if I'm looking at my example of order pairs, the range should be 6, 4, 7. And we don't have to resay the 4 again because we already wrote it after the 6. So it's just the set of Y values. Now, at times, they'll ask you to put the domain or range in order. So this set would be 4, 6, 7. So, a couple things you need to know. When writing sets, we use the curly brackets or braces, that's what they're called. Ascending order is nice, but not required. And never list an item more than once. Like the 4 in the example above. There was 2 4s, but I don't list them twice. I only need to list it once. All right, so get a calculator in your hand. The equation below is an example of a function, okay? Whenever I see any function notation or equation, we're going to put into y equals. Then you're going to hit second graph to get to table. So I'm going to do that with you. So we're putting this equation into the calculator. So go to the y equals button. Let me get mine up. Make this a little bit bigger. And type, let me clear whatever function or equation's already in there. Clear it out. And put in 3x plus 1. Then second graph to get to your table. Okay, I'm gonna show you something, guys. I'll remind you on this. I'm gonna remind you, but I want to show you something real quick. Okay, so if you look at our table values and our answers here, they want the x comma y, the order pair. So they need you, to put the values that represent the y here. Now, what I just was going to show you something is, you see how my table starts at negative 13?
Yeah.
Like, let's say for some reason someone had to calculate prior to you and your table started like at 100, like a real big number. Like to scroll down, to arrow down would take a long time, okay? So what you could do is if you hit second and then window to go to table set, right there it says table starts at negative 13. Well, I don't want my table to start at negative 13. I want my table to start at 2. Okay? You just have to hit 2, the number, and then keep everything else the same. Just hit enter, and then go back to your table. So if you hit second graph again, there it is. It's starting at 2. So that's something to help you, like when you're problem solving on a test. If you're looking for a real big number, you can just go back to the table to start it at the number you need. Okay, so we should have 2 is 7, right? Then they wanted the value for 5. So I just got to highlight that 5. The y value is 16. And then they wanted the negative 4. So I can go back to my negatives. And we got negative 11. So that should be in on your paper. We should have 7 was 16. Negative 11, was that right? All right, so here's what I need you to make sure you see. Did the equation right here, if the equation produces the order pair 5, 16, can you produce a 5, 7, or 5, negative 3, or 5, 61? Can it produce a different output? If I already have this, can I get different answers? Can that number 5 repeat with a different answer? No. So fill in this into here. This is no. Okay. That's the difference between a function and a relationship. Okay? Or that determines if the relationship is a function. Okay? Right here. One of the relationships below of the function is not. Okay? It's not a function. The way you check, guys, underline the first coordinate of each order pair. We got negative 3, 0, negative 1, and 7. Did any of those numbers repeat?
Oh.
No. If they do not repeat, then it's a function. Okay? So if you look at the next set, we have 6, negative 2, 6 again. It repeated, and see how it had a different value? So it's not a function. Okay? One of the things you're going to have to do today is determine if it's a function or not. Okay? And so this is not a function Because, that's the abbreviation for because, B/C. Because 6, repeat it. Okay? Make sure you know why, because that's what you have to check for. All right, so highlight this key information about a function. A function is a relation that pairs each input, that's your x's, to exactly one, oh, I thought it was on here, exactly one output. In other words, no repeating x's. So that's the key information. Highlight that, please. All right, do we have the front page? Flip it or open it up. Go to the next part. Okay, so discrete, a discrete relationship. This is when you have separate, add this to your separate points. Okay. Meaning, the difference between continuous and discrete is for continuous, I can graph it without picking up my pencil. For discrete, like to plot these points, I would have to put my pencil down, then pick it up, then go to the next point. Where continuous, I can do this graph and not pick up my pencil. Okay? So, a continuous relationship is not separated by points. So, right here, how many discrete points are here? How many order pairs? Close. There's 6. There's 6 separate points. But because this is continuous, guys, right? I can put my pencil down, it keeps going. Do you see this arrow right here? This arrow indicates that it's going to keep going up, 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 up. Keep going. If it keeps going, what is that called? It never stops. Infinity. So since it keeps going, how many order pair there are? Infinite. Infinite amount of order pair. Oops, sorry. All right, so discrete contain a finite number of order pairs, where continuous contain an infinite number of order pairs. So we're going to ask you to determine domain and range. Here's how we're going to show it to you. Your domain, guys, what values represent the domain? Go back to the front page. What values represent the domain? The one. Go back to the front page. What values at the very top are the domains? Huh? X values, yeah. Input, X values. Put X here. Kevin, come over here. So in this In this brace, I want you to list only the x values. What are we listing? Yeah, the first coordinates in each order pair. So -2, -1, 10, 9. Do they have to be in order? No, you don't have to. It's not necessary. It's not required. But it's best to put them in order, okay? All right, what values represent the range? Yeah, that's the y values. So that's the second coordinate. So what is the range? 651. Do I have to repeat the one? No. So is this a function? How do I determine if it's a function? If what repeats? Yeah. Does any values in the domain repeat? So that means yes, guys, it's a function. No x repeats. Okay? Oops. So just add that. It's yes because no x repeats. So I'm going to make my domain the x's. I'm going to highlight that one color. So notice that in a table that is going horizontal, the first row represents the domain. First row is the domain. The second row will be the range. The domain values are 3, 4, and 5. Remember, we don't list the repeated value. The range values 0, -1, 2, -3, and 4. Would this be a function? Where's our proof it's not a function? Yeah, they repeated the 4 and they repeated the 3. Repeats, okay? Now this is also showing a relationship. 3 and 4 is what we call mapping. So highlight this down here. Problems 3 and 4 are called mapping. When we do a mapping, the first set is your x's, which is your domain, and your second set, your second little group is your range. The reason why it's mapping, guys, is because you see how the arrows are pointing from one set to the next, okay? So this is showing that x coordinate 1 corresponds with 3. The arrow points to what it correlates to. So what is 2 map onto? Yeah, so this will be 2, 8 right there. And 3 maps to 7. So your domain, remember this x values are your domain. you would just list 1, 2, and 3. Your y's are the range values. 3, 7, and 8. Oops, that's supposed to be a brace. Would this be a function? Yes. No x repeats. That's correct. Good. Now, if you look at number 4, what are the domain values? Yeah, 4 and 8. Good job. Okay. What are the range values? 1, 6, and 10. Yes. Would this be a function? Where's our proof that it's not a function? Yeah, this 4 right here, look. This 4 maps to 1, but it also maps to 6. We have a repeating 4 with 2 different outputs. So I'm going to put a little star here. Anytime on a mapping, we see a split arrow like that. Anytime we see that on a mapping, this proves not a function. So on a mapping representation, this split of the arrows proves not a function. All right, last section. We're going to now ask you to get domain and range off a graph. So we're going to show you table off of a mapping set and then off of a graph. Does anyone still need this one? Okay. When given a graph, the domain, you have to scan left to right to collect the values. Left to right. When given the range, you're going to scan from the bottom to the top. Okay, so remember, domain represents the x values. This horizontal line is your x axis. So all the way to the left, here is the first point we have right here. What you do is you look at that point and you look down. Where is that on the x-axis? -4. I want to write that at a -4 on that x-axis. And then I find the last point. This is the last point over here. Left to right. Then I look down. Where's that value on the x-axis? This is at 4. So I can show my domain as a inequality from left to right, from low to high. I can write it as a -4 is less than or equal to x, which is less than or equal to 4. Okay? This is what you would do if it was continuous. So like if, and I'm not going to, don't do this on your graph, but this is what I mean. If the graph continuous means I wouldn't pick up my pencil, right? So let's say the graph did something like it started, it went that way, went through, went like that, Okay, you see how that's continuous? That would be my range. Oops, actually I would need it to stop right here, sorry. That would be my range, like that. Okay, left to right. But because, guys, because our points, because to do the point, I have to pick up each pencil. I got to pick my pencil up for each point. So this point is at Sorry, I'm gonna put the order pair 4, comma 1. Write that order pair next to that point. This point over here, Luca. What is the order pair for this point? To get to this point, Luca, do you have the order pair for this point? How would you, this point, the next point I'm going from? Write that down, -1, -3, thank you. And then if I go to this point here, because I got to pick up my pencil to get to that point, what would that order pair be? Because you would have to go 2 to the right. 2, 0, good, 2, 0, good. But then this point up here would be 2, 2. Does that make sense? And then your last point, that's 4, 3. So your bracket, if I'm doing my, because this is not continuous, my order pair would be 4, my domain set would be 4, -1, 2, sorry, -4, -1, 2, and then a +4. You have the order pairs now, so range is the Y values. We're going to go bottom to top. What's our lowest Y value at the bottom? -3, good. Yep, -3. Then as I come up, we would get to this right here, which would be 0. As I come up, I would get to that 1, and then I would get to a 2 again, and then 3. Is this a function? No. Where is it not a function? Because it says Y or Y not. Look at your order pairs. Where is it repeating? Yeah. 2, 0. And at 2, 3. 2, 2, sorry. Okay, so I'm just going to circle these 2 points to show that's not a function. The number 2 repeats. After this part. So the last thing we're going to do, whenever the graph is continuous, when I don't pick up my pencil, it's one smooth curve or straight line, we can do a vertical line test to prove it's a function. So highlight this key information, vertical line test. If there is no vertical line that intersects more than one point, okay, then you have a function. But right here it says, in other words, if you draw a vertical line and it passes through multiple points, sorry, I keep sliding, the relationship is not a function. Okay? So, this example here, I'm going to go orange here. This is a continuous function because I can make this without picking up my pencil. Okay, that's the function, the curve. Are y'all looking at the curve? Okay, now what they're showing you here, you see this dotted line. Stop talking, please. This represents the vertical line. This is your vertical line. So what you have to do is check, does that vertical line intersect the curve? Like touch the curve? Yeah, okay, let's put a point where they touch. I'm going to make it a blue point for me. It touches here, it touches here, and it touches there. It touches 3 times. It intersects 3 times. I'm just drawing an arrow pointing at those intersections. Okay? Because it touches 3 times, this is not a function. There are 3 points of intersection. With the vertical line. For it to be a function, it can only have 1 point of intersection. Okay? Okay, so that's continuous. We're going to worry about continuous functions. And if they're a function or continuous relationships, meaning curved lines or circles, those are actually continuous as well. We'll do those tomorrow. What I want you to do right now is 6 and 7. Off the graph, could you list your domain and range and tell me it's a function? So to help you out, make sure you give the order pair, guys. Like you want to see the actual coordinate of each point. Okay. So like this would be -2, 1, 2, 3, 4, -2, 4. Put that coordinate so you can list it. That's how you fill in the blanks. So this is where we're ending. Okay. Make sure you have this. This is going to go in your spiral.